Next, we're going to review ideal gases and molar mass. First, we'll start off, anytime we're dealing with molar mass, we're going to use the mole. What is a mole? Represented by MOL. It is 10 to the 23rd, 6.022 times 10 to the 23rd of anything. It's actually the number of, the way it's defined is the number of carbon atoms in 12 grams of carbon-12. But it's that many of anything. So it's used for large quantities of atoms, like when we're looking at normal life amounts of matter, then we'll usually use moles to determine how many things are in it. For us, when we're dealing with ideal gases or anything like that, we're looking at the number of total particles. It's a lot easier than writing down all of them just to put how many moles there are, and then have it built into our equations. So, 6.022 times 10 to the 23rd, 23rd, is 1 mole of anything. Doesn't matter what it is. If you have that many of it, it's a mole, kind of like a dozen. We call it Avogadro's number. And the number of moles in something is just going to be its mass in grams divided by its molar mass. And that would be grams per mole. See how the units are going to cancel out? Grams cancel with grams. Moles, 1 over moles gets flipped, so it just becomes moles on top. When you look at the periodic table, for instance, let's say we look at copper. You'll have copper here. You'll have the name copper up there. You'll have 29. This is going to be its atomic number. That's your number of protons. And then down here, you'll have like 63.55, and that's going to be your molar mass. That can be AMU, or, isn't it wonderful that the bell went off? Or grams per mole. Both of them work the same. So you got symbol, name, atomic number, and then we're going to be using this for any time we do types of calculations. So let's do some molar mass practice. What I'm going to do is I'm going to put 6 things up here that I want you guys to solve. I'll pause the video. You guys can look up a periodic table online for this. If you remember the numbers from chemistry, good on you, but you don't need to. Information will always be provided. So once I get through all these, A, B, C, D, E, F, what you guys are going to do, first part here is molar mass. I want you to find the molar mass of CCl4 and NO3. I believe that's carbon tetrachloride and nitrogen trioxide. Then I want you, so this will be molar mass up here. Over here, I want you to find my number of moles for a given mass. If I have 32 grams of carbon tetrachloride or 150 grams of nitrogen trioxide. And then for this last part, I want you to find the number of molecules. This would be in 7.5 moles of carbon tetrachloride and 3.1 grams of nitrogen trioxide. Okay, pause the video if you think you can do this all on your own right now. If you think you're going to need some help, hang out for just a second. I'll do the ones on the left, and then I'll let you guys do the ones on the right. Okay, so for molar mass, I'm going to look at the mass of carbon, which is 12.01, and I only have 1 of those, so I'll get 12.01. For chlorine, it's 35.45, and I have 4 of those. When I multiply 35.45 times 4, I get 141.80. Then I just add those up. 3, 5, and then I'd have that in grams per mole. That's my molar mass of the first one. Now I'm going to do the second one down here. 32 grams. You should be able to use this to figure out that next one. 32 grams of carbon tetrachloride. What I'm going to do is go 32 grams. I want to get into units of moles. I want to get out of units of grams. So I'll put grams down here, moles up there. Hey, grams per mole, that's just this flipped over. Grams per mole, moles per gram. So I'll put 1 mole up here and 153.81 grams there. So this should be a 4. Wait, should it? No, that's right, 153. We're good. So 32 divided by 153.81. And I end up with 0.21 moles. I'm not going to be super picky about sig figs for AP Physics. Chemistry, definitely useful for this. As long as you're getting the idea, that's what I'm looking for. I don't actually know if the AP test even tests for. I don't think they do for physics. On this last one here, I've got 7.5 moles of this. I want to go from moles to molecules. So I'll put moles on the bottom, molecules on the top so that it cancels out. In 1 mole, there is always 6.022 times 10 to the 23 things. Had to raise it a little there to fit it in. Now, when I do this math, a lot of you guys are still the people that use times, 10, caret, whatever exponent. Stop it. I know you think you're going to be okay. Oh, Mr. Gillum, there are ways to do it with parentheses. I know there are, but you will mess it up. You'll find a way. Every year there's one person that says, oh, I'm just going to keep doing it my way, and then they screwed up on the first test. And they're like, oh, Mr. Gillum, how do we use E? Like 2 months into school. Learn how to use it. So if you've got a graphing calculator, I think it's by the comma button. You'll hit second, and then whatever thing has a capital E above it, it'll say EE. I'll show you guys on here. If you look above the x to the minus 1 power, which is above 7, you'll see it's x to the minus 1 above that EE. That just means times 10 to the power of. So when I do this math, I'm going to type 7.5, because I have 7.5 moles, times 6.022, and then I'll hit second E so that I get my calculator to look like this. Then I'm going to type 23 because that's what power it is. There's no need to do anything with 10. E means times 10 to the power of. When I hit enter, this is what I end up with. So I would put equals, and then I'll put 4.52 times 10 to the 24 molecules. At this point, I want you guys to try out the other ones. We'll come back together in just a second and go over them. Okay, so I solved this here. Nitrogen, I've got 1 of them. It's 14.01. Oxygen is 16. I've got 3 of those, so I multiply, add them together, I get 62.01 as my molar mass. I can then use that over here. I divide my mass by my molar mass to find out I have 2.4 grams, or sorry, 2.4 moles. And now this last part's a little more tricky. Hold on, can you see that on there? You can see it, but I don't have my answer, so I'll just write that down here. On this one, the reason that it's a little tricky is because you can't go directly from grams into molecules. You have to use moles as your intermediary. So what I do is I take my mass, divide it by my molar mass to find my number of moles. Then I multiply by how many things or how many molecules are in a mole. So all I'm going to do now is type in 3.1 divided by 62.01 times 6.022 E23. And what I get is 3.0 times 10 to the 22 molecules. Remember, anything that's on top gets multiplied, anything on the bottom gets divided. The last 2 things we have to talk about in this section are what an ideal gas is. So an ideal gas is a gas in which all particles all particles have perfectly elastic collisions. And have no intermolecular forces. Now, I know some of you hear that and it brings back terror from your chemistry days, but don't worry about it. Basically, all this is saying to us is that when they hit each other, none of the energy of the collision is stored internally. So if you get like diatomic molecules, we'll talk about this a little more, some of the energy can be stored in like a spring. Like the bond is a spring between them, it can store some of that energy. We don't want that to happen for an ideal gas. And the other thing is that they don't really have like the force of the collisions is significantly more important than any forces of attraction or repulsion they feel from each other. It just makes them act like billiard balls bumping around on each other. As long as it behaves like this, we can use a lot of unique equations that help make the math a lot easier. The last thing we have to talk about, though, is STP. What is STP? It is standard temperature and pressure. So for what we're doing, and I know they've slightly changed it, but 0 degrees Celsius is standard temperature, 0 degrees, or 273 Kelvin. And then for pressure, it is exactly 1 atmosphere. So 1.013 times 10 to the 5th pascals, or exactly 1 atm. And that'll be it for this section. Hold on. One last thing. The volume for an ideal gas at STP, so this is the volume, and make a note of this because you'll use this in problem, of 1 mole at STP equals 22.4 liters, which is equivalent to 2.24 times 10 to the minus 2 cubic meters. Keep note of that because a lot of people will get to tests and stuff and be like, bruh, I didn't remember that. But that's all that'll be for these notes sections.